Hello. In this video, I'm going to explain to you the concept of overriding and polymorphism. Let's begin by creating a project. I call it as overriding and polymorphism. Let's add a program to this so we can test certain points. Consider a class called shape. Now, shape does not represent any valid shape. So we would like to have certain functions such as what kind of a shape is that? So I'll say here public void info, and then I'll just type here just a shape. We may also want to print the area of this particular shape, so we'll call it as public void print area. But since this shape does not have any significant format, so we'll say that can't print the area of this shape. However, there are different types of shapes such as circles and triangles. So let us create a class that inherits from this. So I'm going to go create a class called circle that inherits from shape. Let's click finish, and then we'll define the circle class. Now the circle class has supposed to have a radius, so let's give a private double radius, and then we will construct that circle with a default constructor as well as a constructor that takes a field. We'll also provide setters and getters. And let us now try to create an object of this shape. Now I can say shape S1, and that's just a variable of shape type. I can say S1 equals to new shape, and then S1.info, S1.print area. So we get this default outputs that says just a shape, can't print the area. Now incidentally, since circle is also a shape because of inheritance, so I can always say S1 equals to new circle, and I can also supply some radius, and then I'll type s1.info, s1.print area. Now we need to import. We will execute this code, but even though circle is a valid circle object that has a precise area and information, it still says that it is a shape and it just has that area. Now this is where we can now override the methods from this and say, hey, the methods in the shape class is not applicable for this. We need a modified version of the same. So I'm going to go type here info, and this info method we can actually override to print information about the circle. I can say that here a circle object with radius of radius units. So now if I execute my program, at least the information is changed. Now we will actually change that to print the area also. So let's go to the circle and override the print area. So I'm going to go print over here. So we have this print area, and we will like to print this area. So we'll say here area of the circle is, and then I'll type a formula that generates or that calculates the area. So I'm going to go type here math.pi multiplied by radius and radius again, and that's the square unit. So I'll type here SQ units. So to say that it's a square units. Now if I execute the code, you will see that it's actually printing the area of the circle. Now let's consider another object such as triangle. Triangle extends shape. So triangle is a shape. So we now have all the methods that that info and area, print area, they're all available over here also. Let's create the members for the triangle. private double base and height. We'll add a constructor that takes no parameter as a better practice, constructor that takes fields as a convenient way of creating objects, getters and setters. And then of course we would like to override both the methods. So we go to override implement methods, info and print area, both of them. Now the info is just going to print that the triangle, object of triangle with base equals to percentage probably f, and then I'll say height equals to, you can also use percentages for all data types, so we can use percentage %s, but of course it's supposed to be printf, and then I'll type here base and height. Similarly, the area also can be printed in the same fashion as printf, and I'll type area of triangle is percentage as square units. And what is that? And that is supposed to be half into base into height. So that's how we got it. Now let's go back to our program and let's create here S1 equals to new triangle, and we'll supply some values such as 12.34 and 45.67, and then I'll type s1.info, s1.print area. We'll also introduce new lines in each one of them so that they look separate. When I execute the code, you can see that we got, of course, we didn't use a new line characters over here. So that is the reason why we get everything in the same line. Let's just go and check this out once more. And you will see that we got first time just a shape, can't print the area, and a circle object with radius of so and so, an object of triangle with so and so base and height, and then the area. So we got all these things correctly. All right, so small typo. Now, what is polymorphism here? Now, as you can see, the line number 15, 20, and 25, all of them are identical to the compiler. So compiler doesn't know what to print here. So the result of that is something different. Now, how is this done? Now, generally, the associating a method call to its body is done by compilers in most of the languages, but in Java, associating a method call to a method body is not at the time of compilation. Now, that's why it is called as a late binding. Binding is basically the binding of a method call to a method body that happens at the runtime. So depending on what is the object that this S1 refers to, now the actual method is also being exhibited by that particular object itself. So when you say S1.print area, currently S1 is pointing to a shape object, so it is printing the shape area, which is can't print this area. When you say S1.print area in line number 20, now it is currently pointing to the circle object, so the circle object's print area function is invoked, which actually prints this information. Similarly, line number 25 is also calling print area function, but at this time it is pointing to a triangle object. So because it is pointing to a triangle object, the output is coming from the triangle object. So a polymorphism is where exact same lines of code may behave differently depending on what is the object that it points to.